Hey Nines, welcome to Wednesday's math session. Today we're going to continue on from what we were talking about on Monday, where we're taking a look at finding side lengths of right angle triangles and finding the missing side using trigonometry. But today these triangles are slightly different to the ones we were looking at on Monday. See if you can see what's different between triangles A and B to the ones we were looking at on Monday. Now, it's not that triangle B has two pronumerals, that's not it. If you can spot the difference at this point of the video, you have some serious IQ. While you're trying to spot the difference, trigonometry, people are probably wondering, why do we use this? Well, it's to initially astronomers used trigonometry to figure out the distance between planets based on, light and all that sort of stuff from the telescopes they were looking through. And also sometimes you can find estimated distances or heights of buildings and things up in the air. Okay, so that's sort of the main aim of, or the main uses of trigonometry. If you haven't spotted the difference, that's okay. If you have spotted the difference, let's see if you're correct. So our task here in the triangle on the left is to find the pronumeral here, which is x, to 2 decimal places, which is exactly like what we did on Monday. But the triangles are different, not in the sense of dimension and the type of triangle. What you'll notice is where the pronumeral is labeled is different. What do you mean, Ed? Let's find out together. So the first step is still the same. So I'll write the steps on the left one, and then we won't do the steps on the right triangle, or triangle B. So step one still is to, step one, label given sides. Label given sides, okay? In terms of where the angle is. So the interior angle here is 35 degrees. We're given the sides 5 and the side x. What is this x side called? The x side here is opposite to the right angle, and it's the longest. If you said it's the hypotenuse, you are correct. So here we've got the hypotenuse. Okay, so we've got the hypotenuse, and what's this side here with the 5 called? If you said the side that's got the 5 on it is called the opposite, you are correct, because it is the furthest from the given interior angle. Okay, so here that's not given is the adjacent, so we don't need to label that because it's not given to us. There's no value there for us to find. Now that we've labeled the given sides, step 2 is going to be, so step 2, choose so, ka, or toa. So in other words, choose the right trigonomic ratio. Are we given O and H? Are we given A and H? Are we given O and A? Well, if you said we're given O and H, you are spot on, because we have the H and we have an O. So sine is going to be our trigonomic ratio, and the trigonomic button we press on our calculator to solve for x. So now that we've established sine's the trig ratio we use, step 3 will be writing the ratio out and subbing the ratio in, subbing the values into the ratio. So sub values into ratio. All right, so sine, what does this mean? This means sine theta, which is our generic ratio, equals the opposite opposite divided by the hypotenuse. And remember, the reason why the acronyms are so Katoa is because the ratios are in that exact order. Opposite on hypotenuse, adjacent on hypotenuse, opposite on adjacent. All right, with the sine one, we're looking at opposite on hypotenuse. So, therefore, with the values in this triangle, what replaces theta? Well, the angle on the inside replaces theta, and we're looking at 35 degrees. So 35 gets placed in theta. We don't need the degree symbol, just because it'll stuff up the calculator. The opposite side length is 5. And the hypotenuse side length is x. Oh, that's in blue, is x. From the information given above. Now, can you spot the difference between the triangles we did on Monday to the triangles we're doing right now? All right, the hint is in this line of work. What's different about this line of work compared to the previous lesson? I'll give you a minute. Right, if you said the x is no longer at the top, it's at the bottom, you are correct. Okay, so all the triangles in exercise 3G, when you get to this line of working, once you've subbed in the triangle's value, the x is no longer the numerator, which is on top of the fraction. It's now always going to be on the bottom of the fraction. How we solve for x, as you know, with linear equations in this circumstance, is going to change. So previously, if x was on top, we could just chuck the number to the other side and just multiply the left side with that number as whatever the denominator number was. All right, but now we can't do that because, well, x, if we chuck it to the other side, is not going to be super meaningful. But in saying that, there's two ways to go about this. The first way is the long way, which nobody in year 9 chooses to use because there's a shortcut. I'm just going to have a think. If we were in class and I were to ask you guys this question, do you guys want the long way or the short way? I imagine you guys are all saying, just show us the shortcut. And I think I will. I'll show you the shortcut, and then if anyone's interested in why we do it, please email through and I'll show you the proof, which is the long way. In short, long story short, to get x by itself, that's our step 4. Step 4. Get x by itself. Here we've got x in blue. Get x by itself. How do we do that? We just switch the sine 35 with the x around, and then we get x by itself. Again, people are like, well, why do we do that? Again, email through and I'll show you the proof. But to keep a long story short, we switch these two around. Okay, so what we end up with is, therefore, x will end up on the left side because it's switched with sine 35. All of a sudden, the 5 is still on top. But now, sine 35 is going to be on the bottom. Okay, and then this will tell us our side length x. Okay, once we input that into our calculator. So grab your calculators out. Make sure you you can either divide or find your fraction button on the scientific calculator. Now the fraction button, to access that, if you have a green Green Casio, I think that's what they look like, the green, blue, and white one. You've got this function. For some of the older scientific calculators, you might just have to go divide. All right, so if you go 5 divided by, press the sign button. Whoop, that's not it. Let me try again. So press 5 divided by, or press the fraction symbol and type in 5 as a numerator, and then divided by sine 35, shut the brackets on the 35. Remember, put the angle in brackets. This equals 8.72. So see if your see if your scientific calculator gave you the answer 8.72. All right, that's how you go about figuring out the answer or the side length when the unknown side ends up on the denominator. Let me know if you have any questions as soon as possible. Right, let's check out triangle B now. So without labeling the steps, we have two sides to figure out. We have the X side and we have the Y side. To do this, we have to figure them out one by one. So if you're ever given two pronumerals, you got to figure out X first, and then you figure out Y second. Can you figure out Y first and then X second? Sure. It's just alphabetical. Right? We figure out X before Y, just as an alphabetic preference. There's no right or wrong. You can do either or first, but let's figure out X first. So here, let's find the X length. So the X side length. It's literally just doing what we did on the left side twice. All right, so the X side length here that we're trying to find. Well, how we go about this is we still label the given sides. We don't label the Y side. So the given side is X and 19. If the interior angle here is 28 degrees, what side is the X? The X is not the hypotenuse because the hypotenuse is the Y side. That's the side opposite the 90 degrees. So what's this X side called? If it's touching the angle, it is the adjacent because it is next to the angle. That's what adjacent means. All right, so the X side here is the adjacent side to the interior angle of 28 degrees. What's the 19 side called? So if the Y side's a hypotenuse and the X side is the adjacent, the Y side, sorry, the 19 side is the opposite. Right, so now that we've labeled the given sides, we have to choose. So, ka or toa. Are we given the opposite and hypotenuse? No. Are we given the adjacent and hypotenuse? No. Are we given the opposite and adjacent? Yes, we are. We've got the opposite. We've got the adjacent. So now that we've picked our trigonomic ratio to use, what we do now is we go and write the formula out. So therefore, tan theta equals the opposite on adjacent. So the next step we have to do is we have to sub in the values that's in our triangle. So our interior angle here is 28. Okay, the opposite side is 19. Oh, let's keep the colors consistent. So the opposite is 19 and the adjacent side is X. As you know, with what we did on the left side. Once we get to this step, we switch, okay, the x with the trig ratio on the left side of the equation to get x on the left side of the bracket, sorry, the left side of the equal sign. And then the tangent's going to be on the denominator of the fraction. And so what we get now is we have the calculator step. We go and input 19 on tan 28 into our calculator, or 19 divided by tan 28. And what you should get is tangent 28, shut the brackets, you should get 35.73. All right, again, we don't have any units. And yeah, that's going to tell us this x side here is equal to 35.73 from what we figured out just here. Hopefully we've got enough space. Do we have enough space? Yes, we do. We have enough space to find the y side. All right, so let's rule this part off. So we found the x length, and now to find the y length. Okay, I'm hoping this makes sense so far. My recommendation is once you've figured out the x, we rub out our labeling and we start again. So now let's take a look at the y length. So what did we write? Y side length. All right, so the y side length. We ignore the x. Okay, the x here is now irrelevant, just like the y side was irrelevant when we were finding the x. So what sides are we given? What's the y here? The y side is the longer side, and it's opposite the right angle, which confirms the y side to be the hypotenuse. And then the 19 side is opposite the interior angle of 28 degrees, and that is our opposite. So let's write out our trigonomic ratios. We have Toa. We are given the hypotenuse and the opposite. So which one do we use? Does sine have the hypotenuse and the opposite? Yes, it does. Cosine doesn't. Tangent doesn't. Okay, so sine is going to be the ratio that we use. From here, we write the trig ratio formula out, as we always do. I forgot the therefore. The therefore 3 dots is important just to signify when a new line of working is starting. So people reading the documents mathematically don't get confused. All right, so the opposite we had in red, hypotenuse we had in blue. And let's take a look at the values. So our theta, anterior angle, is 28 degrees. Hypotenuse is y, 19 is our opposite. All right, so let's plug those values into the formula. What we have is sine theta, that's a fail. It's meant to be now 28 equals 19 divided by y. Okay, how did we get 19 and y? 19 is the opposite side, y is our hypotenuse side, and we've just replaced the opposite and hypotenuse with these following values from the triangle. From here, we can see that the pronumeral is at the bottom, so we do our exchange, our switcheroo. And so what happens is the y ends up on the left side of the equal sign. The 19 is still on top, but just below the 19, we have sine 28 degrees. Sine 28. Right, this is the part where you input the 19 on sine 28 into your calculator. So what we can say now is, well, therefore, y equals 19 on sine 28. So 19 on sine 28, which is going to give us 40.47 because we ran into 2 decimal places. 40.47. All right, so we figured out y's side length is 40.47. We figured out x's side length is 35.37. Along with a 19, we now have all 3 sides of this right angle triangle. That's all for exercise 3G. If you can jump over to the textbook, in the old textbook, that's questions 3 and questions 4 you need to do. In the new textbook, that's questions 1 and question 2. Let me know if you have any issues, and that's all for Wednesday. Thanks, everyone.